In 2017, Earth encountered an unusual object from deep interstellar space. We didn't know it then, but something from another star had entered our solar system. It was unlike anything ever observed, and it took years to understand its nature. Now, in 2025, a second mysterious visitor is approaching the Sun, but this time we can track it in real time. On October 19, 2017, humanity received its first confirmed visitor from beyond our solar system. The object was named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. It was the first interstellar object ever detected passing through our cosmic neighborhood, a true scout from the vast emptiness between the stars. Its journey was immense. Scientists estimate it traveled for millions, perhaps even hundreds of millions of years, drifting silently through the Milky Way galaxy before its trajectory brought it into our system. Discovered by the Pan-STARRS 1 telescope in Hawaii, this celestial traveler offered an unprecedented, yet fleeting opportunity. By the time we identified it, the window for observation was already closing. It had made its closest approach to the Sun, its perihelion, a month earlier and was already speeding away, never to return. This left astronomers scrambling to gather as much data as possible before it vanished back into the interstellar void. Initially, its extreme trajectory suggested it was a comet, flung from another star system. But as telescopes focused in, a puzzle emerged. It had no coma, the fuzzy envelope of gas and dust that forms when a comet's ice is heated by the sun. It was just a sharp point of light. So, if not a comet, was it an asteroid? That didn't fit either. Observations of its brightness revealed a strange, periodic variation. It was changing in brightness by a factor of 10 every 7 to 8 hours, suggesting it had a bizarre, highly elongated shape, perhaps like a cigar or a flat pancake tumbling end over end. Its speed was also extraordinary. At its peak, it was moving at over 87 kilometers per second relative to the Sun. This is far too fast to be gravitationally bound to our star, confirming its interstellar origin. It was on a hyperbolic trajectory, destined to escape back into the galaxy, but the greatest mystery was yet to come. After passing the Sun, instead of just slowing down due to gravity, Oumuamua accelerated slightly. This non-gravitational push was a tiny but unmistakable deviation from its expected path. For comets, this is normal. It's the result of outgassing acting like a gentle rocket engine. But Oumuamua had no visible outgassing. This behavior indicated an internal force was acting on it, a force we couldn't see, meaning it couldn't be just a simple inert rock. The scout from afar had left us with a profound riddle. Its brightness pulsed every 7 hours, revealing a non-round, elongated or flat object rotating as it moved. These unusual features led to speculation about artificial origins, though no evidence confirms this. Comets naturally accelerate due to sublimation acting like thrusters, but Oumuamua showed no visible gas, no dust, and no tail. Still, it behaved like a comet. Its trajectory pointed toward Vega, a historically significant star, though this doesn't prove it came from that system. It passed 24 million kilometers from Earth, close in cosmic terms, but too far for detailed study. In 2019, a second interstellar object appeared, Borisov. Unlike Oumuamua, it clearly behaved like a natural comet. Then, on February 25, 2023, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, in South Africa, flagged a new, faint object. Initially designated A10B-MLZ, its trajectory was quickly identified as unbound. It was not from our solar system. This was the third confirmed interstellar visitor, officially named 3I-ATLAS. It was discovered at a remarkable distance of 4.5 astronomical units from the Sun, roughly the distance of the main asteroid belt. This early detection was a game-changer for astronomers. Unlike Oumuamua, which was spotted only after it had already looped around the Sun, and even Borisov, which was closer upon discovery, ATLAS was being observed on its long journey, the inner solar system. This provided an unprecedented opportunity. A chance to study an interstellar object in its pristine state before significant alteration by solar radiation. Scientists could watch in near real time as the comet woke up, its ice is beginning to sublimate and form a surrounding cloud, or coma. and it is a substantial object. Initial observations suggest a vast coma stretching up to 20 kilometers across. The solid nucleus at its heart is estimated to be a formidable 11 kilometers wide, making it significantly larger than the nucleus of Halley's Comet. This immense size implies it could survive its passage around the Sun, offering a prolonged window for study. Most strikingly, its origin story is written in its path. 3I-ATLAS arrives from a completely different direction than its predecessors, plunging toward our system at a steep inclination. This trajectory suggests it doesn't hail from the galaxy's thin disk where our Sun resides, but from the much older, more diffuse, thick disk. Objects from this region are ancient relics. This makes 3I-ATLAS a potential time capsule, possibly over 7 billion years old, carrying secrets from a much earlier epoch of the Milky Way's history. As 3I-ATLAS journeys through our cosmic neighborhood, its trajectory offers a rare and extended viewing opportunity. Unlike its fleeting predecessor, Oumuamua, which was gone almost as soon as it was found, Atlas will grace our skies for months. Its path is a classic hyperbolic trajectory, a clear indicator that it is not gravitationally bound to our Sun and is merely passing through on its interstellar voyage. The object will reach perihelion, its closest point to the Sun, in late September, passing just inside the orbit of Mars. This proximity to our star will significantly increase its brightness, making it a prime target for observation. Following its solar encounter, Atlas will make notable passes near several planets, including Mars, Venus, and eventually Jupiter. However, its trajectory ensures it will miss Earth entirely. As it continues its outbound journey, a celestial alignment known as a solar conjunction will occur. From our perspective on Earth, Atlas will move directly behind the Sun. We will lose sight of it in the Sun's immense glare around mid-October. This period of invisibility will last for several weeks, but patience will be rewarded. By early December, it will re-emerge from behind the Sun, once again becoming visible to our telescopes as it heads toward the outer solar system and beyond. This long observation window is a gift to science. The fact that Atlas is visible for months provides an unprecedented chance to analyze its composition, rotation, and behavior in detail. Furthermore, its predictable path opens up exciting possibilities. Existing spacecraft currently orbiting Mars or Jupiter, such as the Mars Reconnaissance Orbiter or the Juno probe, might be in a position to perform opportunistic flybys. By slightly altering their orbits, they could potentially get a close-up look at this interstellar traveler, gathering data that is simply impossible to obtain from Earth. This is a significant advantage we never had with Oumuamua, whose speed and trajectory made any form of interception a technological impossibility. The potential for an in-situ encounter with an object from another star system is a tantalizing prospect for planetary scientists worldwide. As for Oumuamua, a natural explanation may be that it is a fragment of nitrogen ice from a distant icy world. Nitrogen sublimates invisibly, explaining the acceleration without visible gas. Whether natural or something else, these interstellar objects help reveal the ancient processes shaping our galaxy, and the most important discoveries are still ahead.